So next, we're going to shift gears just a little bit. We're going to talk about a couple of different areas related to veterinary medicine and what are some things that, as an industry, we need to be keeping in mind within that as we move forward in the program this afternoon. So I'd be remiss if I wouldn't have at least one slide talking about ASF and giving just a big picture overview of ASF. Here's a map of the global situation. Red is countries or regions where ASF is currently circulating. We're up here in the Power Cat land in central United States. And as a reminder, the Dominican Republic and Haiti are not very far away from us here in the US. And going back to last summer, these two countries were first infected for the first time since the late 70s, early 80s with ASF, and it continues to circulate within both domestic as well as wild pigs on the island of Hispaniola. So very, very close. Not a lot of progression of that disease within that area where we are in a pretty fortunate situation that it is an island. But again, ASF is very, very close to our borders. We need to remain very, very vigilant and do everything we can to keep this very devastating disease out of our populations of pigs. Another health area that's been getting a lot of attention, a lot of discussion over the last couple of years, diarrhea. Diarrhea after the time of weaning. And here's some data that I'd like to thank Dr. Almeida at Iowa State Vet Diagnostic Lab for providing some of this information that we can talk through today. Here's some data over the past 15 years or so summarizing all of the diagnoses given for post-weaning diarrhea. Within this, a lot of it's not specified. A lot of that's based on whether or not they were able to perform various diagnostic tests. But by far, one of the more common causes or more common diagnoses associated with post-weaning diarrhea is E. coli. So if we look at that a little bit closer, this is along the vertical axis is the number of E. coli diagnoses in any given year, again going back to 2007. And over time, here we are in the most recent 2022, we've seen a pretty steady increase in the number of E. coli diagnoses going through the VDL with a pretty large spike in the last couple of years. What gets really interesting about this information is that a couple of depending on the stage in which that pig is still nursing or post-weaning, what stage post-weaning, what specific E. coli can vary quite a bit. But what's been really interesting in some of the diagnoses in recent years is K88 E. coli has remained relatively stable. However, over the last couple of years, the diagnosis of F18 E. coli has spiked quite dramatically. A number of causes for this, a little bit outside the scope of what we'll be able to talk through here today. But really, a lot of the challenges with E. coli that we're seeing largely are attributed to F18. So with this, there's a lot of reasons why that may be. Shifts in that specific pathogen a little bit, shifts in the genetics we use as an industry most commonly, number of other different factors. However, one of the projects that Macy Reeb did within our SCW facility here on campus as part of an undergraduate research project prior to starting her master's program was looking at ways to disinfect a facility or the efficacy of that cleaning and disinfection process. So the bars on the left represent a number of different samples from the facility: a feeder lip, the surface of a feeder, a rubber mat, metal flooring, and both the outside and inside of a cup drinker. The bars on the left represent those samples collected before washing with high pressure water, a detergent, and a disinfectant. And then the bars on the right represent those samples collected from those surfaces after that disinfection step happened. As we see on the vertical axis is the log colony forming units per sample. And again, this is important to remember, this is on a log scale. So from a change of 2 to 3 is a 10x, 10 times as much CFU, colony forming units, with each one log change. So as expected, the process of cleaning and disinfection generally reduces the amount of bacteria present on those surfaces. That's a good thing. Another key takeaway is that even after disinfection, those surfaces are by no means sterile. And specifically, when looking at a few of those surfaces, I'll draw your attention to this green bar. We see about a 2 log difference between several of the surfaces, feeders, and some others, metal flooring. This rubber mat has about 2 logs more than many of the other surfaces. And again, on a log scale, so a 10 and 100 times. So this green rubber mat has 100 times more CFUs of bacteria relative to many of the other surfaces. All to say that cleaning and disinfection generally reduces bacterial load, but here highlighting the importance of focusing on some of those key areas, making sure we properly sanitize, get those very difficult to inspect and very difficult to clean areas, making sure we're doing a good job of facility decontamination can help reduce bacterial environmental load and get that next group of pigs coming to the facility set up for success. Many have seen this data as well. So this is some data we generated with a very strong collaborator located in Southeast Asia, and we've really focused on the importance of feed trucks and people and the transmission of African swine fever virus in that region of Vietnam. So we know that feed trucks and people are really important. One of the areas that we haven't really had a good answer on how to address is what do we do with that other half of samples? Once we find ASF in a feed mill, what do we do about it? We really haven't had a great answer for that yet. That's where this project comes in. And this is, unfortunately, we don't have all the data finalized. Give a lot of credit to Olivia Harrison, the PhD student leading up this work, as well as Dr. Chad Polk, who's been the faculty lead, doing a tremendous job of getting this project set up and really spending a lot of the spring and summer months in BSL-2 containment at our feed mill on campus, being able to answer that question. Once a mill gets contaminated, what do we do about it? How do we clean that facility? So the project has a couple of different key components. We're working with 3 viruses present here in the US, PRRS, PED, and Seneca virus. We're inoculating those into the feed mill and then exploring different ways of going about cleaning that feed mill. The first experiment focuses specifically on flushing procedures to flush that material potentially through the system. And the second experiment focuses on general decontamination of that facility as a whole. So here's the experimental setup for the first experiment. We take some equipment, a mixer, bucket elevator, discharge spout, pellet mill, and a pellet cooler. We run a negative batch of feed through that equipment. Essentially primes the system, gets that feed into the mixer, into the boot of the bucket elevator, gets everything ready to go. We then run some inoculated feed, again, PRRS, PED, and Seneca inoculated feed. And then we have our flush step as the next batch, and then run 3 negative batches of feed through the system to see what transmission or what carryover of pathogen there is from one batch to the next. And within those flush steps, after that PED, Seneca, or PRRS virus inoculated batches of feed, there's a number of different flushing steps. And some of these are focused on ground corn with the addition of a liquid formaldehyde, a dry formaldehyde product by itself at full concentration of that product. And then going back to some previous work that had been done focused on rice hulls and the abrasive nature of some of those, the thought process being to essentially flush or scrape that material out of the system. For this project, Olivia has been using an abrasive flush, which is a calcium bone builder mixed with some ground corn to allow that to flow a little bit better, as well as the inclusion of a formaldehyde product. So some different treatments from a straight ground corn flush compared to a highly abrasive calcium bone builder, as well as both some dry and liquid disinfectant type products to help address and understand what this would have on within that flushing of that system after virus inoculation. The next is the decontamination treatments. Once that pathogen is in the mill, what do we do about that facility as a whole? So some of the treatments explored within this is a control, which we know is highly effective. When we take this facility into these research projects, inoculate pathogen into the feed mill, we can disassemble all that equipment, high pressure water, then we disinfect with multiple rounds of disinfectants, and then we heat up that whole facility for 2 days, 48 hours at temperature. We know that's highly effective at eliminating virus from a feed mill. However, it's not all that practical in nearly all situations. But nonetheless, that was our control, or a positive control, our gold standard in this experiment. Here's an example of a chlorine dioxide-based product. It was applied in the environment and distributes within that airspace, getting into some of those tough-to-reach areas. So this was an area, the chlorine dioxide, that was utilized within the experiment, utilizing small shop vacs, essentially, vacuum cleaners to remove some organic material from certain key places in combination with chlorine dioxide, heat alone within the facility, or the combination of multiple steps with the portable vacuums and heating the facility. So some really interesting stuff in terms of how can we know we probably can't in most situations achieve the gold standard, but what are some practical ways we can reduce this contamination from that facility? Again, Olivia's been working real hard on this project. The data's been generated in terms of PCR data. However, for a decontamination project, we need to understand if those samples could then cause infection in pigs. So we'll be working with Iowa State going into this winter to take some of these samples, get them into pigs, to understand if these processes were in fact effective at reducing the ability for those samples to cause infection in pigs. So a real exciting project. A lot of work's gone into this over the past year. So we're getting there. We're generating some good information so far, but still have a little bit to learn before we can share some final results. I'd also like to, you guys have seen a very similar document to this last year, based on a lot of the questions that we get in relation to what products are in the marketplace with varying degrees of evidence to support viral inactivation properties. We've put together this document and have introduced several updates over the past year to it. I learned how, thanks Cassie for the QR code to the website, so if anybody wants to see those, and you've seen several QR codes throughout the day. But the goal of this document is to provide continuous improvements as more data is generated to allow producers, veterinarians, nutritionists to make the most educated decisions within your production system as it relates to products available with data to support viral inactivation properties in feed or ingredients. I'd like to wrap up with talking about some resources that have been generated over the past year. Going back to what we've learned, both here domestic with some of our endemic pathogens in feed mills and the feed supply, also what we've learned over in Asia, is that identifying gaps in biosecurity can really drive improvement within the system. However, the way we go about collecting those samples can vary quite dramatically. Lots of different ways you can collect an environmental sample, process an environmental sample, and ultimately analyze that sample. So what Grace has done as part of her PhD project is to help take some of this information, compile recommendations in a relatively straightforward and simple format with some fact sheets, user guide of how to best go about collecting and analyzing these samples. So Grace did a great job with this. This is all available on the website for anybody wanting to assess potential gaps in biosecurity practices, both in the feed supply, but also any other biosecurity specific practices within your production system. Likewise, Grace, Olivia, and Allison have done a great job putting together several fact sheets, again, on the website. Lots of resources available for those in the audience and beyond, addressing feed safety for a variety of different audiences, a summary of salmonella. Again, some nice work summarizing in relatively simple and straightforward forms various areas of importance to feed safety. And I'd like to wrap up by talking a little bit about the U.S. SHIP program. And we had Dr. Roger Main here last year to provide a big picture overview of the program. I want to give, there's been a lot of progress made within that program over the past 12 months, and want to give some big picture updates of where that program stands today. So really, the U.S. SHIP program has several overarching goals. One of the more important and forward-facing goals is to increase the preparedness for foreign animal diseases such as ASF or CSF. And this is really focused on preventing that initial contamination, that initial introduction from occurring, response, or how do we go about responding to that initial diagnosis, and ultimately, how do we recover as an industry, and what does our continuity of business look like moving forward? An additional goal of the SHIP program is not only focusing on those high-impact foreign animal diseases, but also what can be done, or how can those practices help us in terms of our endemic diseases that we deal with quite routinely? Can these biosecurity practices and such help us in our day-to-day operations today, in addition to preparedness for FADs? And then finally, the whole program is based on the National Poultry Improvement Plan, which is a long-standing plan that focuses on several key areas of biosecurity, testing, and has really been highly, highly effective within the poultry industry, with a very large percentage of that industry participating in that program. So the U.S. SHIP program was guided after the NPIP program, and really is focused on several key areas: sampling and testing, confirming that various areas are free from certain pathogens, most notably in the early stages of the program, ASF and CSF, focused on animal traceability and understanding the network connections of where animals have been to help improve our response to a foreign animal disease outbreak. And then finally, biosecurity. And biosecurity is focused on several key areas: biosecurity site plans, several areas of biosecurity. But one of the areas that our team here at K-State has been involved with is focused specifically on the area of feed biosecurity. And we've been very fortunate to have been invited to participate in these discussions focused on feed biosecurity within the U.S. SHIP program. So what does participation in the program look like today? So all those states highlighted in green have currently expressed or are participating in the U.S. SHIP program today. So this green on the map represents nearly all large swine producing states in the country. So even in a period of about 8 or 9 months of gathering enrollment within the program, a very large number of states have participated thus far. And in terms of number of sites participating, roughly 40% of the sites in the U.S. swine industry today estimated are to be participating in the program and currently enrolled in the program today. And again, enrollment in the program started in June of this year. So in just that short number of months, there's been very, very quick uptake within the industry, and very, very optimistic and very fortunate to see these very large numbers and a high degree of participation from the U.S. swine industry. So finally, my last slide. I'd like to wrap up, and if you are interested as a producer, what would some of the next steps be? So each state has what's called an OSA, or an official state agency. They help administer the program within the specific state. And the state of Kansas, the official OSA, is the KDA. So for those that would be interested in getting your site enrolled and within the U.S. SHIP program, Dr. Sarah McReynolds and the KDA would be the contact representing the official state agency for the state of Kansas. Within that enrollment is relatively straightforward. There's a short biosecurity survey. There's a number of other different participation requirements within that. Again, largely at this point focused on biosecurity practices. There are several key program standards that have been passed over the last couple of years, focused on preventing and responding to an ASF or CSF outbreak. So with that, the U.S. SHIP program has seen tremendous advancement over the last couple of years. It's on track to be taken over and be codified into a fully functional USDA program in the next couple of years, and that transition expected to occur in about 2024. So just a couple of years out, and would encourage anybody with any questions about the program or interest in involvement, please let myself know. Jason, Cassie, Chad would be happy to address any questions. And the KDA and Dr. Sarah McReynolds would be the official state agency for the state of Kansas. So